Hello everyone, today is 20th December. We will be solving today's lead code problem. It's an easy level question. The question states that we are given an integer array prices that represents the prices of various chocolates in a store, and we are also given some money. This represents the initial amount of money that we have. We must buy exactly two chocolates in such a way that we still have some non-negative leftover money. Basically, what this means is that let's suppose I have an array which looks something like this 1, 2, 2, and I have some money. Let's say I have 3 in my account initially. I can only buy the chocolates if the sum of the chocolates is less than or equal to the money that I have. Basically, I cannot buy chocolates which is worth more than what I currently have. That is what this line is trying to say. It should be a non-negative leftover money. It can be 0, it can be some positive values, but it cannot be negative value. Also, we would like to minimize the sum of the prices of the chocolates that we buy. Now, that basically means that we need to find the least element in our array and the second most least element in our array. Why? Because choosing this combination will always yield the least amount of sum that we can get in an array. Anything else will always result in a sum which is greater than the sum of these two elements. Now, in order to do this, there are basically two ways. First is I can sort the array. Let's suppose I have 1, 3, 1 and 2. I can sort this array to get 1, 1, 2 and 3, and then the minimum element will be at the first index. The second most minimum element will be at the first index as well. 0th index and first index. I can take the sum, let's suppose 1 plus 1. I can compare it with the money that I have. If this is less than or equal to the money, I can return the difference. Otherwise, because I cannot make it, I will simply return the money itself. Let's just say return money. This is one way of solving this question. The time complexity will be n log n, because this is the time complexity required to sort the array. The space complexity will be O of 1 because we are not using some other data structures. Let's just code this up first, then I will move to the second approach. Leetcode. I think int by choco is the name of the function. It expects the array prices and the initial money. What I will do is I will first sort the array prices.begin, prices.end. This is how we sort arrays in C++. I will find the minimum element which will be at the 0th index, prices of 0, and I will find the second minimum element. This will be at the first index. I will take the sum. Basically, let's just define the sum as well. Int sum is equal to minimum element plus second minimum element. My bad. Second minimum element. If this sum is less than or equal to the money that I have, I will return the difference. Otherwise, I will simply return the money because I cannot buy the chocolates. Let's just try to submit this once. Run. Okay, and submit. Okay, great. We have a successful submission. Let's try to solve it using a different approach. What we will do is, let's suppose the only thing that we need to find is the minimum element and the second most minimum element. This is the only two elements that we are concerned with. So we can get away with finding this element without sorting the array itself. What we will do is, let's say I can initialize two variables. I can initialize a minimum element which will be some big number in the beginning, and we will also initialize some second minimum element which will also be some big number in the beginning. What I will do is I will traverse through the array. Let's suppose I have this array 1, 3, 1, 3, 2, 2. I will check if this element is less than the minimum element. If that is the case, what I will do is I will update the second minimum first. I will say that the second minimum is whatever the minimum element currently is, and the minimum element will be the new element which is even lesser than the minimum element. So prices of whatever that index is currently. And if the element is just less than second minimum and not less than minimum element, in that case we will simply just update the second minimum only. We will say that the second minimum element is equal to that index only without updating the minimum element itself. Let me just code this up. You will understand better what I'm trying to convey. This is the first way. Let's just do it the second way. Let's initialize two variables, a minimum element, which is some big number, and some second minimum element, which is some big number in the beginning as well. I will start traversing int I is equal to 0, I less than the size of the array I plus plus. I will see if prices of I is less than the minimum element. That basically means that we have a new minimum element. In that case, I need to update the second minimum element first. I will say that whatever the minimum element currently is, that will be the second minimum element, and the minimum element will be whatever we found, just the least element that we just found. If this is not the case, if the prices of I is just less than the second minimum element, and we also need to make sure that this is not equal to the minimum element itself, because in that case it will always be less than the second minimum element. So we need to make sure that the current element is not equal to the minimum element. If this is the case, what I will do is I will update the second minimum element only. I will say that this is prices of I. Once we are done with this, once we are done with the traversal, we must have the minimum element and the second minimum element of our array. I will find the sum again. This will be equal to the minimum element plus the second minimum element. I will see if this sum is less than or equal to the money that we have. If that is the case, I will return the difference. If this is not the case, in that case we will simply return the money only. Okay, let me just copy and paste this again. Let's see if this gets passes or not. Submit, and we are getting a wrong answer. This array. Let me just code this up over here. Let's see why we are getting wrong. Let me just print the minimum element and the second minimum element to see if we are able to find the correct pair or not. Second minimum element. Let's just create a new array. Let's say 1 3 2. Okay, wait, just take this array only. Just take this array only. And let's just do cout ob dot by choco and pass this array. Hit run. Okay, expect some money as well, right? So let's pass 60 here. Hit run, and 1 and 2 is the pair that it is finding as the least element. Okay, wait, but there is 1 and 1 only. So this is where we're getting it wrong. Maybe let's just make it greater than or equal to. In that case, I think I should be able to find 1 1. Okay, that I'm able to find 1 1. Okay, let me just submit this again. Control V, hit submit. Let's see if this gets passed or not. Obvious. So we get a submission. Okay, fine. So this is the correct. We are not actually. We should have the prices of I greater than or equal to the minimum element. Okay, the time complexity for this approach should be O of n only, because we are finding the minimum element and the least second minimum element in single pass only. So this improves upon our previous time complexity. The space complexity will still remains O of 1 only. That is it for today, guys. Thank you for watching.